All right, let us see some more examples. In these examples, we will not only find out the interval of convergence, but also, not only find out the radius of convergence, but also find out the interval of convergence, and then we will check the convergence at the endpoints of the interval. Okay, so we'll have to check at each of the endpoints. All right, so find the interval of convergence of the following series and also check the convergence at the endpoint of the interval. Okay, that's what we want to do. So here, so what is this a power series? Yes, it is a power series where a n is equals to -1 to the n over n, right? And then what is c? C is equals to 0. You see that? This is x minus c to the n. So c is equals to 0. Now, we want to see whether this series converges or not. So usually, you can, so the idea is you first try, is it a geometric series? No, it is not, because you see that n in the denominator there, right? It is not the geometric series. Now, if it was a geometric series, then we know how to check the convergence of the geometric series. Now, another thing you can try is you can try the ratio test. Okay, let us do that. Limit n tends to infinity un plus 1 divided by un. Why did I do un? Because an is that thing. So the whole thing I'm assuming as un, right? What do you do here then? Limit n tends to infinity. So absolute value will get rid of that -1 to the n. So you can write x to the n plus 1 over n plus 1, right? There is absolute value there. Times divided by un will make it n over x to the n. You see that? This is what you get. Okay, so so what do you get then? So basically you get this as so you see that if you cancel that out, because x to the n plus 1 is x to the n and x to the n will cancel out, so what is left is xn. So that will be like xn over and then n plus 1, right? X times n over n plus 1. But when you take limit n tends to infinity, this is what you get. Okay, so when you take the limit, you will get basically absolute value of x only, because when limit is n tends to infinity, x is like a constant. You can pull that x mod x out and then take the limit n tending to infinity and then do n over because n is positive, right? So you don't need absolute value, n over n plus 1. So when you plug in the limit, you will get infinity over infinity. So the L'Hopital's rule will give you that derivative of the top is 1, derivative of bottom is also 1. So basically you get absolute value of x. Okay, now you know that the convergence of the ratio test is this series converges if the value of the limit is less than 1. You see that? That means, so this converges if value of the that L, we denoted by L in the ratio test, right? The whatever limit you got, if this is less than 1, that is, what is the interval? -1 through +1, right? Because that means what? That means this means -1 is less than x is less than 1, right? That is -1 to 1. Again, it says check the convergence at the endpoint. So when at x equals to 1, +1, what do you get? That limit become what? That the series becomes n equals to 1 through infinity, -1 to the n times x to the n is just 1, right? And then 1 to the n is 1, right? Over n. You see that? So this will become an alternating series, right? You see that? This is the alternating series. Does this alternating series converge? What do you think? Yes, it converges, because you see that here the term of the alternating series, that is 1 over n, it is what? It is positive. Okay, it is decreasing. You see that? Those are the conditions. And then the limit n tends to infinity is 0. So it all satisfies 3 conditions of the alternating series. So this series converges. At x equals to 1, it converges. Okay, when x equals to -1, what do you get? At x equals to -1, you get summation n equals to 1 through infinity, right? You got -1 to the n times x to the -1. You get -1 to the n, because x to the n, that x to the n become -1 to the n, right? You see that? So and then you get just n. So basically when you multiply that, you will get -1 to the 2n. So -1 to the square to the n, that is just 1 over n. Summation n equals to 1 through infinity 1 over n. See that? But this is this diverges by the p series test, right? Diverges by p series test, because it is like 1 over n to the p is equals to 1. If p was greater than 1, it would converge, but since p is p series test, since p is less or equals to 1, that diverges. Okay, so what is the interval of convergence? So the interval of convergence, interval is what? It converges at positive 1 but diverges at negative 1. So you write negative 1 parenthesis and then 1 bracket there. That's what you get. Okay, this is how we find out the final interval of convergence. Okay, let us see some more examples here. So the another example that I'm taking is, I think it is question number 18 from your book. Okay, so you see that this is also a power series, right, with a sub n equals to negative 1 to the n plus 1 times n plus 1, right, and then c equals to 0 here. You see that? You see that this is also x minus 0 to the n in the previous example. That's why you were saying that the radius of convergence, the radius is 1 here. If it was not x, but radius of convergence is 1 here. You see that? So, and then you see that negative 1 through 1, and then, but the radius of convergence was not x, so you can just write not include the radius of convergence there. Okay, now you see is equals to also 0. Now we want to check again the same thing. Let us find out the limit n tends to infinity, absolute value of en plus 1 over un. Okay, what do you get? So absolute value will get rid of that negative 1 to the n, so you get n plus 1 plus 1, because you see that un plus 1 is, you replace n by n plus 1, plus 1 times x to the n plus 1 absolute value, divide by, there is no divide, there is divide, because un is n plus 1 times x to the n. You see that? So if you do that, you will get, let's cancel that x to the n and x to the n. What you get is mod x, and then you get n plus 2 over n plus 1. You see that? This is what you get, n plus 2 over n plus 1, and I'm taking that absolute value x outside, because this x, we don't know what is the sign of x, but n are positive. Okay, n are positive, that's why I'm just writing outside the root. Now if you take the limit of that, limit n tends to infinity mod x times n plus 2 over n plus 1. You see that this mod x is like a constant, because limit n is tends to infinity, so that limit goes here. Okay, and when you plug in the limit, you will get infinity over infinity. Okay, so mod x is there, and then limit infinity over infinity, so use the L'Hopital rule. What do you get? You get that is 1, right? So basically this is mod x. Now by ratio test, here also ratio test. Okay, ratio test. By ratio test, the series converges for mod x is absolute value of x is less than 1, that is negative 1 to 1. Now we want to check the convergence at negative 1 and positive 1. Okay guys, so let us check that. So again, as we did in the last example, when x equals to 1, what happens? That series becomes the summation n equals to 0 to infinity negative 1 to the n plus 1 times n plus 1. That's what you got. Okay, so does it converge? Actually it diverges. Why? Because by the nth term test, if divergence test or nth term divergence test, whatever you say, this goes to infinity, so it diverges. So it diverges at the right endpoint. Okay, now let us check at the left endpoint. Okay, if you take when x equals to negative 1, then summation n equals 0 to infinity negative 1 to the n plus 1. Okay, and then n plus 1, and then what is x value of x here? Negative 1, right? So negative 1 to the n as well. So what do you get? Again, you will get, basically this goes to n equals to 0 to infinity, right? So negative 1 to the 2n plus 1, negative 1 to the 2n plus 1. Okay, and then times n plus 1. But what is the negative 1 to the 2n plus 1? It is same as negative 1. You see that? Because -1 to the 2n is +1, and then times -1 to the 1 is -1. But anyway, this diverges by the divergence test again. So what is the interval of convergence then? Then the interval of convergence, interval is just -1 to 1 because it diverges at the both endpoints. Okay guys, so this is how you do it. Next question, I want to do question number 22 from your book. Okay, so here also, so is this a power series? Yes, it is a power series with n equals to, an is -1 to the n over n plus 1 times n plus 2, right? And then c equals to 0 again because there is x to the n. Okay, x minus c to the n makes it c equals to 0. Again, let us use the ratio test. Most of the time we use the ratio test for this. Let us do that. So limit n tends to infinity, absolute value of un plus 1 over un. Okay, so what is un plus 1? Absolute value takes that -1 to the n out, so limit n tends to infinity, x to the n plus 1 over n plus 2 times n plus 3. Do you know why did I do that? This is value of un plus 1. Replace n by n plus 1. Okay, times, divide by un, but this will become n plus 1 times n plus 2 divide by x to the n. Okay guys, so what you get here is you can write absolute value of x because you cancel that x to the n and x to the n, and then limit n tends to infinity, right? And then what you get n plus 1 times n plus 2 divided by n plus 2 times n plus 3. That's what you get. Okay, when you take the limit using the L'Hopital rule, you will get that limit is 1. So basically you got absolute value of x there. Okay, that's what you got. So by ratio test, the series converges. By ratio test, the series converges if mod x, absolute value of x is less than 1, that is -1 is less than x is less than 1. So this is the interval of convergence, you see, but we want to check at the end point at x equals to -1 and +1 also. You need to check that. Okay, so what happened at x equals to +1? Let us see that. So let me write down that when let me move that color band down there. So when x equals to +1, what do you get? How does the series look like? The series will look like summation n equals to 0 to infinity, right? -1 to the n and then 1 to the n, because that will replace by 1, right? Over n plus 1, n plus 2. If you use the alternating series test, this converges. Okay, and next is when x equals to -1, then this becomes what? N equals to 0 to infinity, -1 to the n, and then this will, you will replace that x by -1 to the n. So -1 to the 2n will be 1 over just n plus 1 and then n plus 2. Does this series converge? So again you can use the ratio test again, okay, or you can use the comparison test, because this series is lesser equals to summation n equals to 0 to infinity 1 over n square, because you see that when you multiply, when you FOIL the denominator here, okay, when you FOIL the denominator, you will get n square plus 3n plus 2. Okay, now if you eliminate n 3n plus 2, you will have just 1 over n square left. If you eliminate, if you make, because the denominator is smaller here than here, okay, when the denominator is smaller, the whole ratio is the whole series is the bigger. So, and but this series converges by limit, not limit, just a comparison test. Okay, you don't need limit. So converges by comparison test. Okay, so what is the interval then? The interval of convergence, the record interval, final answer, interval is basically -1 to +1 with the bracket, because you see that this is the interval of convergence we found, and at both endpoints it converges, meaning that the total interval of convergence is -1 to +1. Okay guys, so one last example that I want to take is, let us see, example number 4 here. That means from the book, that is example number 25. Okay guys, this is also similar, not much different there. Okay, so what I'm going to do here is I am comparing this. Is this a power series? The answer is yes, where an is -1 to the n plus 1 over n times 9 to the n. What is c? C is 4. You see that? Because there is x minus 4 to the n. Okay, so what we get here is basically, now use the ratio test. So limit n tending to infinity, absolute value of un plus 1 over un. What do you get? Limit n tending to infinity, right? The absolute value will get rid of the -1 to the n. So what do you get? You will get basically x minus 4 to the n plus 1 over n plus 1 times 9 to the n plus 1, right? Times, divide by un. What is un? That will the reciprocal, times the reciprocal of the denominator, right? That will be n times 9 to the n, divide by, you get x minus 4 to the n, absolute value. Okay guys, you see that? What can you cancel there? So basically this 9 to the n and then this 9 to the n will cancel out. What is left is just 9. Similarly, x minus 4 to the n and x minus 4 to the n will cancel out. What is left is just x minus 4. Okay, so basically you can write this as like this, equals to, let me write down what is the remaining part here. So x minus 4, okay, divide by 9, x minus 4 divided by 9, the absolute minus 4 has absolute value, times limit n tends to infinity, right? What is left there is n over n plus 1. So to find out, so what did I do here? Because you see that 9 to the n, and then because this 9 to the n plus 1 is 9 to the n times 9, right? You cancel that, one of that out, 9 is left. Similarly, x minus 4 to the n plus 1 is x minus 4 to the n times x minus 4. That x minus 4 was inside the absolute value, I pull that here, and then that 9 that is left in the denominator, I pull that 9, pull that here in the front. Limit n tends to infinity, n over n plus 1. We don't need the absolute value there because n is positive there. You see that? N starts from 1, that's why. Now when you use the L'Hopital rule here, you will get 1. This guy is 1. So what you get is x minus 4 over n. Now by the ratio test, what do you get? You get the series converges. Oh, this is not n, this is 9, right? Converges if you get x minus 4 over 9 is less than 1. Okay, so x minus 4 over 9 is less than 1. Okay guys, so so if you simplify, if you multiply both sides by 9, what do you get? You get x minus 4 is less than 9. You see that the radius of convergence is 9 here. Okay, now let us simplify this, okay, to find out the interval. So how do I simplify that? Is to simplify this, you get -9 is less than x minus 4 is less than 9, and add 4 on both sides, plus 4 plus 4. What do you get? 9. So you get -5 is less than x is less than 13. Okay, not 113. So this is the interval of convergence. Again, we need to check at the boundary. So how do I check at the boundary? Is, let me check that at the boundary at x equals to -5, left boundary. Let us check. What do you get? If x equals to -5, you will get -1 to the n plus 1 times -5 minus 4. So you will get n equals to 1 through infinity, -1 to the n plus 1 times -9 to the n divided by n times 9 to the n. So what do you get? You can write this as -1 to the n plus 1 times, you see that, -1 to the n times 9 to the n divided by n times 9 to the n. You see that 9 to the n and 9 to the n cancel out. So -1 to the n plus 1 times -1 to the n become -1 to the 2n plus 1, which will be -1. Okay, -1 over n. That's what you will get. Okay, so that's what you will get, -1 over n. at x equals to -5. Okay, so but -1 over n diverges, right? So summation n equals to 1 through, I forgot the summation here also, 1 through infinity -1 over n diverges by what? So it diverges, right, by the let's say it is not an alternating series, right? You can move that negative sign at the front, and then you see that it diverges by the p series test. Okay, p series test, it diverges. All right, next is let us see at x equals to 13. At x equals to 13, what do you get? The series become 13. Okay, the series become n equals to 1 through infinity -1 to the n plus 1. I'm plugging in 13 for x. 13 minus 4 is 9 to the n, right? 9 to the n over, you get what? You get 9 to the n times 9 to the n again. You cancel 9 to the n. You get basically the alternating series, right? N equals to 1 through infinity, -1 to the n plus 1 over n. So it converts because it is an alternating series with the positive terms, except that sign, with the positive 1 over n is positive, and then n tends to infinity and decreasing, right? So it converges by alternating series test, So what is the interval then? What is the final interval? Let me write down that final interval then. Interval is converge at 13, right? And it diverge at because we will use that one, and we check, so it is diverge at -5, so -5, and then 13 is positive, 13 is bracket. Okay, this is how you find out the interval of convergence. Okay guys, so that's all from section 9.8. all right, thank you.